Anybody else just come in, or anybody else has been here for a while? Do you have any other questions, especially chapter 1, since that's going to be the quiz today, and then I want to show you a few technical things about how the quiz is going to work. Just let me know. Any questions? Oh, cool. Let's see. 1-1. Jeff, go big dude. Are you in the wrong place? You totally are. All right, hold on. Let me open the book. So you said 1-1. I'm having trouble identifying them. All right, let's see what that is. All right, guys. So 1-1, number 46. Here we go. All right. Oh, okay. All right. So this is these problems. Now so to answer these questions, you have to go beyond what they say. You have to think about the situation and answer from that perspective. So, all right. So for example, let's see. Well, what the hell? We'll do 46. They're interested in the proportion of voters in his district who think he's doing a good job. One thing I want to say real quick. What would be wrong if I said the population is all voters in his district who think he's doing a good job? If I said the population was all voters in his district who think he's doing a good job, what's wrong about that?
You can't get the proportion because you need to know you need to know all the voters, not
Exactly.
just
If your population is everybody who thinks you're doing a good job, won't you always get 100% who think you're doing a good job? That seems a little, well, that seems a little like what a politician would do, but let's pretend like this is a good straightforward. So what would the population actually be for 46?
all voters in the politician's district.
Bam, right? And then a sample, you basically can take the word all from the population and change it into a number of randomly selected whatevers, right? So all voters in his district is the population, and then you can say 78 randomly selected voters in his district, or even just say a subgroup of the voters in his district. You guys, does that make sense here? Are you guys all right? Okay. Yes. Yes, just like we said the other day when we did these examples. Yes. Yeah, and that's what they mean up here by give examples where appropriate. Right? The parameter is not the same as the population, correct? I had a few people tell me the parameter and they just told me with the population. No, parameter does not mean population, or else why would we have those two words? What is a parameter? Fundamentally, what is a parameter? In what way?
Numerical description of the
There we go. It numerically describes the population. So right now, the two big ones are the average or mean something, or the percentage of something in the population, right? So they basically tell you right here, the answer, you just have to change this bit right here. This bit right here, you got to change it to match the population. So the parameter would be the proportion of all voters in his district who think he's doing a good job. And the statistic is going to be the same damn thing, except you replace this with what the sample is. I really want you guys to get that. That's it. The statistic and the parameter are the same thing. They just both talk about two different groups. That's it. So they could both be an average something or other, or they could both be a percentage of something or other. Maybe, is that all right? You guys okay? All right. All right. Anything else? No, no, no. The word all pretty much is going to go with the population, because the population's got to be every single thing that you want to describe. No, I don't, what's happening right now? All right. How else can I put this? So the population has to be the entire group you want to describe. And the sample has to be a subgroup of that population. If you're trying to say what percentage of the people think he's doing a good job, your population in your sample can't be only people that think he's doing a good job, or else you're always going to get 100% approval, right? So like I said earlier, the population would be all voters in the politician's district. And one sample you could use would be like 78 randomly selected voters in his district. Is that all right? Okay, I'm going to assume that's okay. Then the parameter sample will be the randomly selected. Yes, yes, exactly. Yes. All right. And then the parameter would be the percentage of all voters in his district who think he's doing a good job. That's the numerical description of the population. And the statistic would be the percentage of the 78 or randomly selected, or however you say the sample, who think he's doing a good job. I'm not sure how else to say this. So population and sample are both groups. Population is the entire group you want to talk about. Sample is the group you're going to work with. Parameter and statistic are both numbers. They're an average, they're a percentage of stuff, and they both sound exactly the same, except one is talking about everything and the other one's talking about the subgroup. Okay. Maybe. All right, anything else? Anything else? Because of course, what's happening today? What is happening today? You're like, I don't know, Jeff. What do you mean? Like, what is today? I don't know. Anybody?
Quiz.
A quiz. Yeah, there's
A
a quiz.
quiz.
Yes, a quiz. So the quiz is on chapter 1. So right now is the time to get any questions answered from chapter 1. So if you got your homework looked at and you're like, what the shit does this guy want from me? Why did he cross this thing through, this dork? Then you can ask the dork right now. Here I am. You can ask me and I can tell you, and that's amazing how it works. It's remarkable. It's almost as if you're not out there by yourself. It's almost as if, all right, I'll stop. I'm sorry. Samantha, what's up?
Oh, I can see the quiz on Canvas.
Say again, sorry?
I can see.
You can see.
No, I can.
All right, listen, guys. Of course you can't see the quiz right now. What happens if you go to try to see the quiz? Has anybody tried to yet?
No,
You
it's
can't.
not.
You made it so we can't take it.
Of course you can't see the damn thing because it's not time to take it yet, right? So I love you guys so much. So let me become a student. So right now, I mean, what does it say? Doesn't it say something? Doesn't it give you some information?
No, it's not in the module.
What's happening? So look right here. Everybody can see this much, correct? There's a whole quizzes module, right? And you can see quiz 1, but when you click on it, it says, it says, this thing ain't gonna start till I made it 3:30, just in case we end class early. And can somebody tell me what time it's due? And what day? I don't know where that information would be. I don't know if I...
Tomorrow at 6 p.m.
That's 6 p.m.
19th.
That shit, look at all this information you're giving. I'm sorry. This is new to people possibly. I'm sorry if I'm being a dork, but and I appreciate asking the question. You always want to ask a question if you're not sure about something. So I appreciate that. Okay, but now this, so let me show you this. I got something else queued up. What this is going to look like. I got to become a student real quick. I am a student. Well, that's stupid. When did I become a student? Hold on. All right. Sorry, guys. Let me get this figured out here. All right, here we go. It's got to be. I'll show you again here in a minute. Hold on. All right. Let me see. Scheisse. Hold on. All right. All right. Come on. Work for me. Are you kidding me? Work for me. No. All right. Hold on. I see what's happening. I'm trying to do two things at once here, and I can only do one thing. All right. Let me do this thing, and then I'll go back to our quiz. Scheisse.
Quick question. Sorry for dropping in late.
Sure.
It wouldn't let me turn in my Module 3 homework. Module 3 won't open for me.
You mean Chapter 3?
Yeah.
Well, shit, man. I appreciate that you are. So you finished all of Chapter 2 homework? I don't really need to make sure I understand what you're saying. Who's talking to me right now? Have you finished all of Chapter 2 homework? Or are you talking about Section 1.3 maybe? Or hello? What is happening today?
He's like, never mind.
Where'd he go? When did he say that?
That was
I guess
Billy,
it's-
but I don't see him in here anymore. So
Oh
maybe
no!
His name's
Oh,
Will.
here.
There
Here.
you are.
Sorry.
Talk to me,
I'm
Billy.
mobile. I'm coming back from work. I tried to scan in the homework for the third homework assignment, all of them.
Section
And
1.3. Okay.
It wouldn't let me scan it in, or I might have done the wrong homework. I'm not sure.
It wouldn't know that. So whatever you scan, you submit it the same way always. It has no way of knowing what it is you're turning in. So you turned in successfully 1.1 and 1.2 is the exact same way with 1.3. Nothing's changed. So
Oh, we only had to do 1.3. I was doing the homework for 3.1, 3.2, 3.3
why are you doing that? All right. So
because I thought that was due today. Because I'm
why?
stupid.
No. Okay. Chapter 3 is down here. Chapter 3 is down here. We're not going to start talking about it until June 21st. Right? So
Okay, I was like, why? These concepts are way advanced. I don't understand what's going on.
yeah, of course. We haven't talked about Chapter 3. We're not even done with Chapter 2 yet. Okay. All right.
Oh, okay. I totally screwed up. My bad.
That's all right. Okay. Now,
I was like, this is a lot of homework. I mean, so,
all right.
okay.
Calm down. Now,
All right, I'm out.
stay here. So, all right. Let me make sure. Okay. So everybody, if you go to modules right now, you'll see the tutoring and help stuff here. And then the next module is quizzes. Is that not true for somebody? It sounded like somebody was trying to tell me that was not true. What's happening? What? Can I have one voice at a time? What's happening? Say it again. This is just the way it's going to be today. Okay, I understand. Is everybody okay? Is anybody not able to see this? Okay, I'm going to take that as a good thing. Okay. Now, let me show you. Yeah, the life of a teacher. You get to live it with me. Now, one of you knows this. One of you is sitting there saying, yeah, Jeff, I know this is how it goes. Okay, now, so let me show you. There we go. See Ann shaking her head, yes? Let me try to show you what it's going to look like when you open this quiz. I've gone to a different class of mine from last semester, okay? Because I don't want to show you your quiz, but it's going to be the same as this. So you go to quiz. See how there's a quiz 1 and there's a submit quiz 1, right? So you go to quiz 1. You can read through the instructions. And again, this is not our quiz, okay? You guys with me? Our instructions will be a little different. But you read the instructions. The minute you hit the take the quiz below, you want, for them, they had an hour. So the minute you hit this button, the quiz opens and your little timer starts to run down. If you don't like the little timer, dude, you can hide him so he doesn't freak you out. You with me? And then now, again, this is not your quiz. Don't get too excited. This is from a different class. You'll see your quiz. You can print it out if you want to. You don't have to print it out. You can just do your work on another sheet of paper. When you're done, I just want you to type in the time that you're done, whatever time it is, and then you hit submit quiz. Now, you haven't turned in your quiz yet. So what you do, that's when you go to submit quiz here. It's like submitting homework, right? Submit quiz 1, start assignment, and then see how it looks just like when you turn homework in? Is everybody with me? So you got a button to push at the bottom of your quiz, submit quiz, and then you have to go actually turn in your scan. All right. So what's up? Let me know if you have questions. Okay. Any questions about how the quiz is going to work? So it's due Friday. What did I say? 6 p.m. tomorrow? All right. So what's the question from homework? Go for it.
Number 8 on 2.1, it's asking to build a bar graph using the number of students. For the left side, am I putting numbers or am I putting percentages?
Oh, it just says a bar graph. And then number 9 says using the percentages. So number 8 says showing the number of students. And number 9 says showing the percentages.
Okay, number 9 looked like it was number 10 and I was very confused. Okay, never mind.
Oh yeah, number 9 is a real quick, like, one sentence thing.
Okay, so one with numbers, one with proportion. Okay, cool.
Sweet. All right, guys. Anybody else? Any other questions? Technical questions, content questions? Question about questions? Question about life?
Sometimes I feel like the like was it 46? Not 46. It was around there, but it's kind of confused. Oh, it was the marriage counselor question 1.1, number 47. I guess I was confused because it. Oh, what was it? I need to write my questions down.
Were you here when we were talking about 46 just a few minutes ago?
Yeah.
Okay. So they all work the same way. You're going to have to, for example, for the sample, you could come up with an example because the problem doesn't tell you what the sample is. You could just come up with an example sample. Conjunction.
So I said the proportion of clients she counsels who stay married, that's a question. So the population is all her clients.
Okay, sure.
Okay, and then oh, okay, so then I think I corrected this one. When we correct homework, so for me, I know that the due date is the final.
I'm glad you're saying this. Oh, go ahead.
Okay, so I know that the due date to send in homework corrections are the final. And then you don't look at the corrections or like make notes on it or anything, do you?
I can.
Okay, I was just wondering.
Yeah.
And then on my Canvas, I've submitted corrections for both 1.1 and 1.2, but it still has the 2 X marks.
All right. So what's unfortunate is I don't think Canvas tells you when I haven't looked at it yet. So
okay.
So
yeah, I guess I just
haven't graded I graded some of the corrections that were turned in earlier, but I think you might understand that my focus is definitely on grading new stuff, and I've got an avalanche of new stuff, which is good. So that's going to be where my focus is the new stuff.
And then for section 1.2, obviously I submitted a correction. So I submitted the homework by the due date, and then I submitted a correction after the due date, obviously. Okay. But it says late.
Nobody freak out. Canvas only lets me assign one due date.
Okay.
Right? So if you I can see when you turned in the original thing and when you turned in everybody with me?
Because I don't see my original turn in. I only see
I
the
know.
second one I started
know.
turn in, which is why I was freaking out because it said late.
No. So it thinks when you submit something, it thinks that's your real assignment. And if it's past the due date, it's going to say late. But I know when you turned in the original, I can see everything you've turned in. So I know it's not really late. You with me?
Yep. Okay. Thank you.
Just another beautiful aspect of remote teaching and working with Canvas. Okay. All right, guys. Okay. So we're going to transition now, I guess. If nobody else has questions, we're going to transition back to chapter 2.
Wait.
Oh,
So
yes.
what exactly was due today for homework?
Everything.
Because
So, not everything.
I'm challenged.
All right, let me show you. All right, let me share my screen here. Let me become a student, actually. So right down here, here's your little quick to-do list, right? You see this when you log into Canvas? Do you see this when you log into Canvas, the to-do list? And you can see exactly.
My screen just cut out. I'm sorry, man. I'm gonna be back in 20 minutes. I'm having internet issues.
Okay, but when you first log in on the left, no, Jeff, on the right side of your screen, you'll see a to-do list, and underneath that are assignments that are coming up soon and their due dates. You could also see the due date if you click modules and you look at where you submit homework. There's due dates there also.
Okay, I just looked at homework and saw 3 and just started going. So that was my mistake.
Okay. All right. Okay. Anybody else? All right. So I have a couple of things I want to check with you, see what you want to do here. I don't know if you guys noticed, I activated a few worksheets. Let me become a student real quick. Here we go. So if you came down to unit 2, here's that histogram one that we did together. There's a percentiles practice one here. I don't know if anybody feels like you want some practice with your percentiles. And then there is you can do it, Jeff. Jeff, buddy. There we go. Measures of center practice that I do want to do for sure. So what I can do, if you want to, I could just do the answer key for this and put it up here. And you can do this on your own if you want to, right? Or we could do this together right now. Does anyone have strong feelings either way? I can make this a democracy here for just a second.
We could do a couple together and then maybe the rest on our own.
I agree
Okay.
with that.
Sure. So this very first part is the frequency distribution and frequency histogram. So we did a whole other sheet already about histograms. Oh, here come a bunch of chats out of nowhere. Oh, there we go. I got a bunch of votes for, one person said, give the key, and everybody else is saying, let's do it together, Jeff. All right. So hold on. Let me pull this up a better way. That's what I'm imagining you would sound like if you had told me. Where would this be, Jeff? Jeff, you're always just so ready, aren't you? Get off my back, man. All right, let's see. 160 percentiles. Donde está? I don't know where you are. I will find you. No, I won't. I'm going to give up. Okay, so I'll just download this again. Download. Bam. Bam. All right, here we go. Alrighty. All right. Who's something that you taught will have different result for the book method for percentile. The only difference would be if you're calculating the percentile backwards. Like if I'm asking you to calculate this grade, what percentile is it in? They have a very convoluted way to do that. But otherwise, it's going to agree. Yeah, and I think I addressed this. For small samples, there could be slight differences, but that's when it doesn't matter. For big samples, it's exactly the same, and that's when it matters. Okay, so this is a good little review. Do you guys remember how to get this thing sorted in your calculator?
Yes.
Okay, so let's do that real quick. Go ahead and get that sucker sorted. Get those things sorted.
I don't super remember.
Oh, okay. So let's do this. Is everybody able to access this on Canvas? Are you guys? Anybody?
Yep.
Yes. I'm going to see what happens if I stop sharing. Okay. All right, here we go. You know, the more I do remote teaching, the more I realize I should never become a YouTuber. All right, a streamer.
I think your YouTube videos are fine.
No, like a streamer, like a, I don't know. All right, here we go. So let me share my calculator with you guys, and then we'll do this again here. Hold on, where are you guys at? There you are. Oh, and then you're gonna hide that from me. You suck. All right, here we go. So you go to Stat, Edit, and then I'm gonna clear. This is from yesterday, I think. So then we just plop in. Let me see if I can do this real quick. Just throw these in here. Did I miss anything? Crap. No, I think I'm good. Okay. No. Okay. All right. Okay. All right. Thank God. Oh, got somebody chatting at me. Watching your videos. Okay, sure. All right. No, I'm not saying I'm going to stop posting my YouTube videos, but if I try to reach a wider audience, I don't think that would work. Let me see. Where am I? Where'd you guys go?
How do you clear L1 again?
Oh, if you have stuff in a list, you highlight the list. So let's say I have stuff here. I go up to the list and then hit clear. Do not hit delete. What's happening? You're trying to show me something. So can you push the up arrow until it's on the list, right? What are you trying to show me? Okay. Oh, and then hit clear, enter. No,
Okay,
hit
question.
clear and then enter. Hit clear and then enter. Yeah. Sorry. Okay. I like it. You're like, I'm hitting clear. What's going on? Sorry, go ahead. Who's talking? Go ahead.
Oh, yeah. So I just had a quick question for when you were trying to yesterday, my calculator only has L1 through L6. So then if I go up to L6 and I highlight the box and then I click once to the right arrow, it gives me a new box, but then I don't know how to name it because I run out of.
What's happening? What do you mean? You only need one list.
Oh, yesterday when we were plugging in all of these values and there were like 7 columns.
No. All right. The way I give you data, I could give you data in one big list. I could give you data in several columns, but it's all one piece of like, it's all one variable. It's all.
Oh, so we only use one column, the L1.
Yeah.
Okay.
The only time I would use more than one column is if I had actually different data. Like there's got to be something in the future where we do stuff like there's one problem I do where I do how far you live away from Bronx Pizza versus how much you weigh. Because I used to live right next to the Bronx Pizza and I weighed quite a bit because the pizza is like way too good. So yeah, this is all one variable. You guys, because I like to ask people, how many variables are up here right now on my calculator? Well, I just gave the answer away, but people will tell me 20. No, there are 20 values for this one variable, correct? There's only one variable in this problem. Does that make sense what I just said? What is that one variable in this problem? What's the one variable in this problem?
Test grades?
Test grades. There you go. And how many values are there for that variable? 20.
20.
Yes, good. So of course I'm only going to use one list because I only have one variable. Okay, good. Okay. Now, where'd you guys go? So how do I get this thing in order? That will definitely help me out.
Go to stat, sort
A. Sort A, I like it. And then you have to tell it
the L1.
which list you want to do. I like it. And the lists are all above 1, 2, 3, all the stuff, so forth, so on. And of course, that's like very not satisfying. But when you go back in, now it's in order. Yay, calculator costs so much money. You can put numbers in order. Yay. How's everybody doing? You guys okay?
Mm-hmm.
All right. So I'm going to stop sharing my calculator. I'm going to reshare my what do you call it, worksheet. Okay. Now, getting that data in order is fine, but what's the real first step here to creating a frequency distribution? What's the real first step?
Figuring out the width of the
Good.
column.
So that'll be range divided by number of classes. And again, I was nice to you on this one. So what's the range? What's the highest and the lowest?
99 and 40,
99 and who to what?
47.
47? Okay. Divided by 5. So that'll be 52 divided by 5, which is 10.4,
Mm-hmm.
which we round up to
11.
11. Shoo! Okay, I like it. And that kind of makes sense. It's just what range do I want to give each rectangle, so overall they cover the whole thing. So then I go to make my classes, and I start at 47. You don't have to, but why not? And am I going to make this 58?
No, 57.
No. Good, because this has got to be 58. So that you see the 11 here. So this has got to be 57. I like it. No, Jeff. There you go, buddy. Good job. Good job. There it is, my friend. You're doing all right. It's good to give yourself affirmations as you go. Okay. And now normally I'm going to ask for a relative frequency. On this one I didn't, so you don't have to go that far. I just asked for a frequency distribution, right? Probably because that wasn't really the point of this worksheet, this little thing. But so somebody help me out. You've got your sorted list.
Mm-hmm.
So how many data points fall in here? Sorry?
3.
3?
Mm-hmm.
All right, we'll keep going until somebody disagrees. Everybody with us there? And then how many in the next one?
3.
3? Oh, Jeff, you really know how to make a problem. I think these were the actual test grades, if I remember, but oh well. How much is 69 to 79?
4.
4? 1, 2, 3, 4. Wait a minute. Let me make sure I agree with you. What's going on here? 1, 2, 3. 1, 2, 3. Okay, I like it. 1, 2, 3, 4. Okay, I like it. And then from 80 to 90.
7.
8. Oh, wait.
1, 2,
9.
Oh, to 90?
9.
9. Yeah, I see 9. Yeah.
Yeah.
He's talking to me. Hold on. Oh, okay. Thank you. And then 91 to 100, there's only
1.
1. Okay. So that's a pretty damn good quiz, right? Look at all them up there in the 80s and 90s. Of course, the people down here would not agree with me, but oh well. There's a test. Oh. And then, of course, real quick to do this, what do I have to do here? What do I put down here? I don't put 47.
40, 5.
46.5. I like it. Now you can certainly ask me if you want to do it the other way. You could ask me what that would look like, but nobody is, so I guess nobody does. That's fine. I'm just adding 11 here as I go, and that will get me all the way to the end. And then, of course, I want to be able to get up to 9. So let's do it by 2, 2, 4, 6, 8, 10. Everybody with me? I'm kind of going quickly through this because we already did an example of one of these bad boys. So then I go up to 3 across for those two things. Shapoo! And then I go up to 4.
If you did it the other way, would it be 47 and the next value would be 58?
I did it the other way.
46.5.
It would be 47. Oh, yeah, this would be 47. This would be 58. Yeah. And then 1. Poor little 1 up here. There we go. Okay. How's that? Not too bad, right? Okay. So I want to do that a little bit quickly. So how do I find P17? What's that process?
17% of 20.
Good.
Which is 3.4.
Good.
Do you round it up
Good.
to 4?
So the fourth number will answer. And what's the fourth number?
65.
65?
Yeah.
Okay. And you gotta let me know if you have questions. I'm guessing everybody's cool so far with what's happening. Okay. And P72 would work the same way. I'm not gonna do it. What exactly does this answer we just got mean? Don't tell me that P17 is 65. That doesn't tell me what it means. What does it mean? This answer.
Is that the 17th percentile?
True. What does that mean?
17%.
17% and it's 65.
17% did what now?
Had a grade lower than 65?
Good. There we go. That's what percentiles always mean. That percentage is below whatever the number is. So 17% scored below 65. Okay. And what's the 5 number summary?
The minimum, the maximum,
Yeah.
the
Quarter
quartile.
1, quarter 2, quarter 3.
Yeah. Now, real quick. I mean, the low and the high are easy, right? What was that? 47?
7 and 9.
There you go. See, I did my part. Whew. Now, real quick, like Q1 would be 25%. Is everybody cool with that?
Mm-hmm.
1/4 of 20 is 5. I got a whole number. So what do I need to do?
Get the 5th and 6th value,
Good.
divide by 2.
Jeff. Averaged. There it is. And what is the 5th and 6th? What are the 5th and 6th numbers?
68 and 68.
Oh, cool. 68 and 68. I think the average is 68.
Mm-hmm.
Do. All right. And Q2, Q3 will be exactly the same shit. So let me show you this. Now listen, everybody. Listen very closely. There will be incredibly few times that I will allow you to let the calculator do all the work for you. And it will be really explicit when that is so. I need you on this kind of problem. I need to see this work for everything there, right? Q1, Q2, Q3. You guys with me? But I am about to show you how to make the calculator tell you the 5-number summary by just pushing buttons. So guess what you can do with that? You can check your work, right? Don't try to tell me I pushed this button and I got this. I'm telling you what my work was. No, that's not work. So let me show you. Here's the shortcut. Here's the shortcut. Oh, Jeff. All right. You're going to see a few other things on the way. So we got all our data in the calculator. So watch this. If you hit stat, the next thing over is calc, which is what we want to do, don't we? We want to calculate something. So go to calc. And how many variables did I say there were in this problem?
1.
1. So I want to do 1 variable statistics. And I'm going to tell it list 1. Now, if you have an older calculator, it'll just say 1 var stats on your screen, maybe. Does anybody have something different than what's here for me? Everybody has the same thing I have? Is everybody? Okay, okay. So just go down to calculate. So make sure it says L1. Go to calculate. So look what it tells you. What is this?
The sample mean,
Good. And what the hell is this?
the sum of it.
The sum of the data points. I love it. And it tells you the sum of the data points squared. Why? I don't know. Maybe we'll talk about it later. And then what's this? We don't know yet, right? So this is going to be from section 2.7. So what I want to show you right now is the last 5 things it tells you. What are these?
Low, max.
Yeah, this is the 5-number summary, right? Did
Mhm,
we just calculate Q1? Didn't we get 68?
mhm.
Yeah. So you have a way to check your work now. For
Go back
the
to the paper we were working on.
Sorry?
Can you go back to the paper we were working on, please?
Yes. As long as nobody has questions on this. Okay. Man, this looks like a mess. All right. All right.
I'm just having a blank moment right now. Can you imagine, can you remind me why we did the 5 and 6 average instead of just number 5?
So let me ask you this. What if I have 5 numbers? Which number is in the middle?
Sorry, could you say that again? Someone just came home.
That's right. If I have 5 numbers, which number's in the middle?
3.
The third number is, right?
Mm-hmm.
All right. But what is half of 5?
Oh, 2.5. Okay, we got it. I just remembered because you have to find the one in between because it has to have a certain amount of numbers below it.
See, it came out 2.5, I would round up to 3. So that's why the third one would be the answer, correct? But if I had 4 numbers, what number's in the middle? The average of the 2 in the middle, right?
Yeah.
And what's
wait,
half?
no, for 4 it would just be, it would have to be 2.5.
It would have to be the number in the middle of the 2 in the middle, right?
Mm-hmm.
What's half of 4?
2.
So then I have to average the second and third. So it's
Right.
it's the process. If I just told you that's what you did, you'd be like, why the shit do we do that? I don't know. Let's just do it and make this guy happy. But we actually saw it happen together. We're like, that's got to be what the process is, or else it doesn't work correctly. So now we know if we get a whole number, we average that with the next one. If we get anything else, we round it up, take that number, right? Maybe.
Yep.
Okay. All right. All right. All right. So the other thing I want to do. Oh, crap. Here it is. Okay. All right. This one I want to look at. Where'd you go? There you are. So why? Sorry, guys. There we go. Okay. Computers are weird. Measures of center. So as I pull this up and give you the answer I'm about to ask you, what are the measures of center? Measures of center. I don't know why I'm talking like that. I'm going to tell you one new one today. Go ahead. What have we talked about? There they are. I mean, right? They're the mean, median, mode, and then this is a new one. I don't know if it's going to come up again. I just want to tell you it exists. We'll talk about what the hell that is. So, can you guys just take a minute for me? Can somebody? All right. Who wants to do Group A? Figure out what the mean is. Anybody?
Okay.
Anybody? All right, you do it. Somebody else could do it too. But Melody's got Group A. Who wants to do Group B? Anybody?
I'll do it.
Who's saying that? Jordan. All right, who wants C?
I can do C.
Who said that? Sorry. Who's saying that?
Petra.
There you are. Oh, Petra. You go by Petra. And Group D? Anybody? Nobody? Nobody? Screw you, Jeff. I'm not going to play along with you, Jeff. It's not homework time, Jeff. I'm in class. I don't have to do anything. Anybody? Nobody.
I'll do it.
Thank you, Hussein. Hussein comes in. All right, go for it. And then everybody else can do whatever you want to. You can pick one of these. Just take a minute and figure out what the mean is. Oops, let me give myself some more room here. Why am I doing it like this? I don't know, Jeff. Jiminy Jeeves, Jeff. Oh, you know something? You crazy foo. I know. I could have done that better. All right. Who's got their average figured out? Anybody?
For group A, the mean is 13.
13. Okay.
Same for group B.
Group B is 13.
C is 13 as well.
C is 13. Oh, that's interesting. Lucky number 13.
D is 13.
B is 13. I like it. And real quick, of course it is, right? Real quick, let me see if you guys can go along with me. Do you see how this is, who's saying stuff? These are all 13s. And these add up to 26, which is like two 13s. You guys with me? And then now watch this. Isn't this one less than 13, but this is one more than 13? This is two less than 13, but this is one more than 13. This is three less than 13, but this is three more than 13. This is seven less than 13, but this is seven more than 13. I have no idea if you guys are following what I'm saying, but if I just increase some and decrease others, of course the mean stays the same, right? So of course all of these are the same because I just kind of did that same thing throughout. Now, what about the medians? I think we can all just do the medians very quickly. They're all in order already. So can you guys see what the medians are?
Mm-hmm.
Okay, what are they?
13.
Yeah, they're all 13. All right, and of course the mode is easy as shit. Which number occurs the most for all of them?
13.
Lucky number 13. All right, and you're all like, what the shit, Jeff? What's the point? Would you? All right. Oh, and let's talk about mid-range real quick. Just me saying mid-range. What do you think that represents? The mid-range.
The middle of the range.
Middle of the range. And how do you find the middle of two numbers?
You add them and divide.
Yeah. So what's 20 plus 6 divided by 2?
13.
Holy shit! Sorry. So the mid-range. Jeff, calm down. It's a 13 also, right? So the mid-range is the mid-range. And again, I don't know if this is going to show up again or not. Is high plus low divided by 2. It's the number that's in the middle of the highest and the lowest. That's why we call it the mid-range. What's the range for each of these? That's easy. What's the range for each of them?
14.
14. The range is high minus low. So for each one of them, it's 14. So every single calculation we've talked about so far comes out exactly the same. But would you say that all those lists of data are the same? Are all these lists of data the same? Are all the data lists the same?
No.
Yeah.
All right, now I want to make sure I understand your answer. And saying no, Hussein saying yes. All the analysis we did came out the same. But is this list of data the same as group B and same as group C and same as whatever?
No.
No.
Obviously not. Obviously they're different. So there is a different, now stay with me, stay with me, stay with me. There is something different between these lists of data that the analysis we've done so far does not pick up on. Yes? Can you tell me somehow what the difference is between these data sets? Well, let me do a little more work. Now, the way I've chosen to do this, all of what I've done is going to disappear here, okay? Get ready. I don't know why I chose to do it this way,
Wait.
but sorry?
Wait,
Good.
please.
Sure. I mean, there's not a lot happening here. Let's see.
Sorry, I'm copying it off of your screen instead of looking at my own paper.
No worries. So what I'm about to do,
Right, I'm good.
number 2 says, is exactly what I just asked, right? So number 1 makes it seem like they're all the same, but we can see that they're obviously not the same. Now, I have set this up because I'm a nice guy. So can you guys fill in these real quick? Do you guys understand? I've created the classes already, right? So I just need to fill in for each data set. I need you to fill those in. So for this one, that's got to be crazy simple, right? For group A, there's one thing way down here, there's one thing way up there, there's nothing in here, and then there's everything else. How many data points were there? Crazy dude. Let's see.
I think there was 8 of 13.
4, 5, 6, 7, 8. Okay. So there's 8. Thank you. Does everybody understand what's happening right now? Anybody not understand? So let's see. Tell me what you get for B if you get that done. Let me rewrite those, Jeff. You suck, dude. I know. All right. Okay. So anybody got part B done yet?
Is it 1 for 6 through 8?
Oh, 6 through 8, there's 2, isn't there? Oh, I'm looking at C. Yeah, 1 for that. Okay. All right, we're going.
2 for 9 through 11?
Okay. 2 for 9 through 11?
4 for 12 through 14?
Like that?
2 and 2.
2 and 2?
You're right. I was looking at group C.
Yeah, that's what I was doing too. Don't worry. What about C? C is kind of the boring one. It's kind of interesting. Isn't C just 2, 2, 2, 2, 2? Do I remember that right? And then D, I think, is 3, 1. Let's see if I remember. Is that right so far? I have no idea. I can't remember.
3, 1, 2?
Sounds about right, maybe. Let's see, 5, 6. Yeah, that sounds about right. All right, so everybody, now let me make sure everybody with me, we just made little frequency distributions for each of them. Now, if we call the mean home, right? Which set of data has data values that leave home, that get away from home the furthest? Which set of data is the most spread out? Which set of data has the most data points farther away from home? So what am I talking about? So
A?
Group D?
in A, do you see how all the data is really close to home?
Oh, so
Mhm.
home would be 13 because the mean is 13. Okay.
Yes, the mean is 13. Yes. So it's like you leave your parents' house, but you move in 2 doors down, right? I'm
Mhm.
leaving right there. All right. And then, and of course, which one gets the most furthest away from home? Which one's the most spread out? The most spread out away from its middle?
Group D?
D, definitely. I mean, 3 of them went way the hell to the other side of the world. All right. I like it. Maybe. No. So what I'm trying to get at here is the main difference between the data sets. All of their measures of center are the same. Even their range is the same, but we see that they're not the same thing. So there is one thing different. They are spread out differently. Do you guys kind of understand that? So if I look back up here at them, do you see how up here, I mean, there's just so many in the middle, and then there's only one at the ends, right? Whereas at group D, I've got several that went way out here, and I've got several that went down, and there's only a couple that are still in the house, in their mama's home, in their basement, maybe. I don't know. Sorry. Not to say anything against anybody. I mean, that's fine. Try to stay from paying too much rent as long as you can. Now, so what we're about to do is, if there is something physically different between the lists, we need to be able to analyze that. I want to be able to calculate a number that tells me how spread out data is. Let me say that again. I want to be able to calculate a number that tells me how spread out data is. Wouldn't that be nice? Now tell me, whatever that number is, if that number is supposed to calculate the spread, what would it be the biggest for? Which group would it be the biggest for? Anybody? If I'm going to calculate a number that tells me how spread out the data is, which group would it be the biggest for?
Group
D.
D.
Or group D. Yeah. So whatever that number is, it's going to be the biggest here, and then a little bit less here, and a little bit less for B, and then the least here. I really want you to understand this. The number we're about to calculate measures how spread out data is. And to be more specific, I wanted to, all right, you guys ready? You gotta, now why am I taking so much time with this? Because this idea is gonna be through the entire class. So it's a little tiny bit important. So this thing I wanna calculate, I want it to tell me the average distance from the mean to all the data points. Let me say that again. And let me write it down. Let me make it so I can write it down. Hold on. Oh, you guys have got to go away. All right. So I want to create a number. I want to calculate something where it will tell me the average distance from the mean to all the data points.
Can you put the values back in the box, my man? Sorry, I just got hooked up.
Oh shit. The way I'm doing this, it like permanently goes away.
Oh,
So,
okay.
hold on.
I'll just
I
stick
remember.
with it.
I remember some of this stuff. This is the one I always forget here. I don't know what this was. Frequency B. Who's got that?
1, 2, 4, 2, 1.
There you go. Okay.
Thank you, everybody.
Obviously, D is the most spread out because it has more of its data further away from the mean, and A is the least spread out because it has more of its data right close to the mean. So there were other ways we could describe spread, but this is the way we decided on. How do we describe spread? The average distance from the mean to all the data points. So we're going to create this formula together. And it is always like watching sausage be made when you get to create an equation. So, but is it okay? Well, I don't care. I'm going to call this. Let's take a break right now before we jump into this. And then, so let's come back at 250. Come back at 250. Take a decent little break. And if you need to hang out and ask me questions, let me know. Otherwise, you can go take a break. Let me see. All right. Is everybody back? Everybody make it back? Hello? There's people. I see people. All right. So.
What's up?
So much. Let's do this. So what I'm going to do, I'm sorry, Jordan. What I'm going to do, we're going to take a smaller set of data instead of the 10 data points we were just looking at. Let's take some smaller set of data. And we're going to develop this formula, and then we're going to call it a day, right? Basically. All right. Get over there. Okay. Jump up. Crazy. Okay. Oh yeah. God, I gotta get some new markers. So watch this. Let's say I've got 2 sets of data. You can do it, Jeff. You did a terrible job, Jeff. Make this a 6. There we go. Okay. All right, I've got 2 sets of data. That's a little bit stronger. You go over there. All right. I can't really see that too well, can you? So can you guys tell me real quick which one is more spread out? Not by a lot, right? But which one is more spread out?
B.
B is definitely more spread out. What is the mean of both of these real quick?
4.
4. Is everybody cool with that? Yeah, the mean for both is 4. So I'm going to say the mean is 4. Oh, and now you're worse. What happened to you? All right, poor little dude. Okay, now, we've got to develop a way to figure out this number. I want this number to tell me the spread. So wouldn't that be kick-ass if I could give, so let me ask you this real quick. Let me ask you this. You guys, you know about, we were talking about this earlier, the existence of the website Rate My Professors, correct? Okay. Did you know there's another website that will tell you grade distributions for professors? I'm not going to tell you what it is, but I will tell you that it costs money to use it. Anyway, so what do I mean by that? You can go in, look up a professor and see what grades they give normally for certain classes, right? So let's say you have 2 professors. They're exactly the same on Rate My Professors, and they both give an average grade of C. So is that enough information to determine which one to take?
No.
No, you basically just flip a coin then, right? So what if I told you this? What if I told you that the spread of grades of one of them is larger than the other one? So like they both give a grade of C, but one of them gives anywhere from a B to a D, and the other one gives anywhere from an A to an F. Would that possibly affect? Now, and by the way, let's pretend like we're at university or a four-year college where a D is passing. Are you with me?
Mhm.
All right. Would there be situations where you would take one or the other? Can I point? There it is, Jeff. Which person would somebody take?
Probably the first one.
That's the first
I
one.
take the second one.
Interesting. So what class, if you knew that you were going to kick a class's ass, which one would you take?
The
B.
second one.
The second one? Holy shit. You're not going to take the one that never gives an A, right?
Right.
And I don't know if I'm talking from experience. Maybe I had a class where I got the highest grade and it was a B minus and whatever. Anyways, still, he was waiting for God to come and they would still give them an A minus, whatever God you appreciate. Now, if I thought I was going to die in a class, like I thought I was going to kick my ass, I might take this one. So this is just one quick reason why knowing the spread of things is useful information. So if you could tell me where the middle is, and you can tell me how spread out the data is, those two things together give me a real good idea. You don't have to show me all the data, right? And very often I don't want to see all the data because it could be thousands of data points. I don't want to look at that shit. I want you to give me two numbers that tell me everything I need to know. How you guys doing? And those two numbers will be the center, which we'll use the mean for, and the spread. Okay. Now, what we have determined the spread should do is it should tell me the average distance from the mean to the data points. That is what I want this to do. So that's how we're going to create the equation. Tell me this. Tell me this. If I wanted to know the average height of people in this class, what must I first get?
The data points.
A list of the heights, correct? If I wanted to know the average shoe size of all the people, I'd have to get a list of shoe sizes. Yes?
Yes.
So if I want to know the average distance from the mean to the data points, what do I need a list of?
The data points.
No.
The distance between the mean and the data points.
There you go. Average blank. Well, I need a list of blank, so then I can add them up and divide by how many there are. Correct? Are you guys with me?
Yes.
So if I'm like, I need to get the average fill in the blank of shit. Well, then I first have to get a list of whatever the shit that is, and then I can average them, right? Of course. Okay, I love you guys so much. But it's this idea in mathematics about taking an idea and connecting it with a formula, with a process. And what we do is we look for keywords like average. Okay, I know how to find the average. If I could just figure out what these are, I know how to find the average. So let's do part A. Let's do for group A. Let me write this like this. All right, there's the data, right? Now, what do I do to figure out how far the data points are from the mean?
Add and subtract.
Mm.
Well, I mean, subtract.
Subtract, exactly. Subtraction is related to how far apart things are, correct?
Mhm.
You guys with me? Okay. So then I'm going to do this. So I'm going to label my column to tell myself what the shit I'm doing. So here's all the x values. And then I want to do the x minus the mean to see how far away it is. Right? So what do I get here? The mean is 4 for us here, right? So what's this?
-2.
-2. And of course, these are all going to be
0.
0. Is that cool? Because there's 0 away from 4. That's amazing. And then 6 is going to be 2. It's 2 above 4. I like it. But what do I get when I add these?
4.
0.
I get 0. No,
Zero.
-2. Now, stay with me. I'm gonna kind of truncate this a little bit because I want to be able to fit all this in and have time to talk about it. We could use absolute value. One reason we don't, without getting into a lot of the detail, does anyone know what an absolute value looks like if you graph it?
No.
It's always the positive version of the
Sure.
number.
What letter does it look like if you graph an absolute value? Does anyone know? It looks like a V. What's the absolute value of 1?
1,
1. What's the absolute value of negative 1?
1.
1. See, that makes a V then. Right? Yes?
Yes.
Okay, maybe. Math does not like hard corners like this. In fact, would we like to be in this plane if the plane was following this? Welcome, thank you for choosing us, and bam, we're all dead. We can't survive that turn. Are you kidding me? So that's kind of silly, but I don't care. So there's a lot of problems with functions that have these hard turns in them. All right, there's actually more to the story, but there is a reason we chose not to use absolute value, and this is a part of that reason. So what's another way? So the problem we have right now, I want you to really understand this, is you got some negatives and some positives. If I do this, it will always equal 0, always. That sucks. I don't want this to always be 0. That's not going to tell me anything. So I need to make these positive. I don't want to use absolute value, so the other way I could do it is just to square them. Is that cool?
Mhm.
Yes, if I square a real number, it will always be positive or 0, right?
Mhm.
Okay. Which means what am I going to have to do at the very end? If this represents dogs people own, isn't this going to be square dogs?
Mhm.
Do I want to have a bunch of little square dogs running around? What am I going to have to do at the end?
Square root.
Square root. So the very last step we're going to do is the square root, so I can kill the stupid squaring I had to do. Why did I have to do the squaring? Because the freaking negative screwed me over. You guys follow?
Yeah.
I don't want you to, there's a lot of shit going on. Okay, I want to calculate an average. Okay, so I need a bunch of distances. Oh shit, they always add 0. Damn. Let's square them so the negatives go away. So they don't make 0, but I got a square root at the end, of course. Maybe you guys are with me, I don't know.
Yeah.
You were hoping this would be simple, but of course it's got to have some weird shit happen. It just does. It's not math's fault, it's just weird shit. So of course, when I square this, what do I get?
4.
Good, thank God. Nothing here should be negative, right? So 0 squared is 0, 0, 0, 4. Okay. So what we're going to do is we're going to find the average square distance, and then we're going to square root. And make sure you guys are cool with that. So I want to find the average distance. There were some problems with this. Damn. All right, let's compromise. Let's find the average square distance and then square root. So how do I find the average square distance? What do I do with these?
Add them and divide by
Add them all up. So of course I get 8, but I really want to make it clear. This is the sum of these, right? Is that cool?
Yeah.
If I add these up, then it's the sum of these, and that is 8. I told you there'd be a lot of this symbol running around. There he is. There he is.
Sigma.
Yes. Now, all right, and never forget this. The spread is basically an average distance, right? There's the sum of the distances squared. So what do I want to do with those? How do I find the average? I add them all up, and then I
divide.
divide by,
5.
in this case, 5. Divide by how many there are, right? So let me finally say the word of what we're doing. What we're doing is called standard deviation. So it kind of makes sense. Deviation is how much you deviate from what's accepted. If you're a deviant, right? Is anybody watching Loki? Not a variant, but a deviant. If you're a deviant, then you've deviated from the norm. Have you guys heard that word before?
Mhm.
So standard deviation is like saying average difference. So that's why we call it standard deviation, because it is the average difference from the mean to the difference. So it's called standard. Jeff, really? Standard deviation. Get in there. And it's going to use the letter that letter. What? What? Start at the belly, go around, start at the belly, go around, start at the belly, go around, right? You can have a fat little dude, you can have a skinny little dude, I don't care, but it's got to be that. And that letter is sigma. And some of you guys are like, no, Jeff, that's sigma. No, this is lowercase. Why did we choose it? Because it's the Greek letter S, and this is standard deviation. Of course, we chose the letter S. Okay. So here's the thing. Sig. What? All right. What I've got though is sigma squared because I haven't. So here's the formula for this. And then to get the real answer, I'm going to have to square root at the end to get the actual standard deviation, right? That's like we said, right now it's squared. And at the end, let me make sure you guys understand that's on this little dude. So let's throw some shit in here. We got the sum of these was 8 and n is 5. So what do you guys get for this?
1.6.
1.6, I like it. So then what's this going to be?
You're gonna square root it.
Yep, square root that.
1.26.
All right, you ready? Got to give me 3 decimal places.
1.265.
5? Is anybody else doing that with us? Is anybody else doing that with us?
Yeah.
Do you agree with that? I do. Okay, 1.265. I like it.
So whenever we're working with decimals, if we have them, you want us to go all the way to the third decimal place?
No. Get ready. Get ready. Standard deviation has got to be at least 3 places. At least. You can go more if you want to, but it's got to be at least 3 places. In the future, we're going to do some stuff like probabilities. I'm going to want them to go to 4 decimal places because I'm crazy, right? So what you could do is you could basically take everything to 4 decimal places and cover your ass if you want to. It's up to you.
Wait, why is it 1.265? It's 8. I mean, it's 5 divided by 8, and then
No. Stay with me. Sigma squared is 8 divided by 5, which is 1.6.
Correct.
How do I get sigma then? I have to take
You have to unsquare it.
square root. Yeah. This, by the way, I know I'm throwing a lot at you, but these are just names. This actually has a name. This is called the variance, which kind of makes sense. Right now, for us, it doesn't mean shit. It's just like I forgot to take the square root. That's what this is.
What's called the variant?
The sigma squared is called the variance. Yeah. It's got a name because it actually has stuff it does, but for right now, it's just sort of a middle step. We haven't finished yet, right? All right, now. There's 2 things I gotta still do. If I were to do all this work again for this list of data instead, would the number we get here be higher or lower? If we were to do it for this data.
Higher because there's greater deviance?
Yes. There's more deviance in this group. My kind of group. No, yeah, there's more spread. So then this number should be bigger because it's supposed to measure the spread. So you guys do it. Do this data. Do exactly what we just did. Do exactly what we just did for this data. I'll stand here. Did I start? Yes, I did. Thank God. I thought I forgot to start the recording again. I'll stand here and somehow still make money just standing drinking Mr. Drink. Oh yeah, I was like, why do I have this so many times? That's right. Let's
What's a signal? What's the sign for absolute value?
Oh yeah, absolute value is just little like that.
Okay.
So you ready? I have a shirt. Of course I have a shirt that has this. No?
Oh, now chapter 3 makes so much more sense. Thank you.
Oh, okay. Because of the vodka? No.
No, because of the lines.
Nobody gets that joke? Okay. Well, we'll see. This isn't too bad, right? So this will still be -4.
So it's just 0.
Well, this one is 0, but 2 minus 4 is -2. 3 minus 4 is negative. Yeah, so this will always add to 0, which is why we have to do this. So you square these. Is everybody okay out there?
So after we do the x minus mu squared, the next step is putting it into that formula.
Yeah. So you have to sum these up.
Okay.
You get 10, right? And then I put it in the formula. 10 here. So now I get 2.
And all this work is just to get it to be positive?
No. That's just to make it positive. All this work is to do this. So we're like, oh, we just need a bunch of these. I got a bunch of those, and they always add to 0. Shit, let's square it. Do you see what I'm saying? Everything we're doing here is making what I need to add up to get an average, right? So I need to make these so I can add them up to get the average. Yes? The one little thing that's weird is I had to square because these dumb things always kill each other. Maybe? Yeah, that's what I get too. I get 1.414. I don't know what 2.236 is. Did you make it right here? You should get a 2 here before you square root, right? Because the sum is 10.
Mhm.
There's 5 data points, so 10 divided by 5 is 2, and the square root of 2 is 1.414, which is bigger than what it was for the first one, correct? Just a little bit bigger. Do you guys agree with me? It's just a little bit bigger. The other one was 1.2 something, and this is 1.4 something. It's a little bit bigger, and that makes sense because this is just a little bit more spread out. I know there's people out there that are like, okay, we just did a bunch of numbers and we did some shit and we got something. Yay. I'm like, damn it. What's important here is the idea. The spread is the average distance from the mean to the data points. So we get a bunch of distances. We squared them. Oh no. But we still add them up, divide by how many there are. And that eventually gets us to this spread number. It represents the average distance from the mean to the data point.
So what were the two numbers that you said were the only two that you wanted?
The two most important numbers for any distribution, and we're going to look at a lot of them this semester. Each time we have a new distribution, I got to figure out a way to calculate the mean, and I got to figure out a way to calculate the standard deviation.
Okay.
Because those, once I know those two things, I know a lot. You don't have to show me all the data. I know where the middle is, and how spread out it is. Fantastic. Okay. Okay. Here's the next big
So
thing.
the spread is 1.414,
Good.
and that would be your answer
Yep.
to the question. Okay.
Yes. So on average, these get that far away from each other. Away from the mean, sorry. And on average, this one got 1.2 something or other away from the mean.
So spread and standard deviation are the same thing.
Same thing, exactly. Spread is really kind of like a one-word quick way to say what standard deviation calculates. Calculates the spread of the data, right? If I ask you on a test or something, what does standard deviation tell you? You better say this shit, because that's the technical definition. Which might be why I wrote it down twice. Okay, now. Everybody ready? I'm gonna keep going. I'm gonna keep erasing. Here it goes. I don't hear anybody. Anybody yelling at me? No? Here it goes. Okay, nobody's yelling. Nobody's yelling. Nobody's yelling. Nobody's yelling. Now, if you're gonna yell, it's too late. All right. So, you ready? You ready? Did anybody notice that I used this symbol, which is a Greek letter? What does this symbol mean again?
Mean.
Population mean. And I used a Greek letter for standard deviation. So this is the population standard deviation. So then, just to cut to the chase, if it's a sample, the formula is going to change a little bit. And why? Let's talk about why real quick. All right, now listen, guys. Listen. All right. Does everybody agree there is an average age of everybody in this class? Yes? It exists, whatever it is. If I randomly selected 10 people from this class, now listen, this is going to be a little weird. Stay with me. If I randomly selected 10 people from this class, would their ages be closer to the average of those 10 people, or would their ages be closer to the average of everybody? That's a weird question, I know.
There's no way to know because you're selecting.
There's a way to know.
Can you repeat it?
If I took 10 people from this class, would their ages be closer to the average of those 10 ages, or would their ages be closer to the average of everybody's ages? I know it's a weird question.
So the 10 people?
Yes? Is that your answer?
Yeah.
Yes. All right, so let me just give it away. I would really hope, now it might be because the question is kind of weird, but obviously they would be closer to their own average than anything else because that average came from them. So what am I trying to say here? I have no idea, I forgot. Oh yeah, the spread for a sample, if I used the same formula I did for this, it's always going to be a little bit bigger than it's supposed to be. Let me say this again. Which way did I just say that? So it's going to be a little bit smaller. There you go, Jeff. It's going to be a little smaller because they're going to be closer to their own average than they would have been to the average of everybody. Okay, maybe. So what I'm trying to say is, if I take a sample, I can calculate X bar, and I can, I can get X bar. And then I can do all this same stuff, but I'm going to have to use X bar here instead of mu. Do you guys agree? If I take a sample of people and I calculate their average, that's X bar. That's not mu, correct? In fact, let me ask you this. Would you expect, I take a sample, would you expect their average to be the same as the average of everybody?
Similar but not the same.
I would put all the money I have on their average being different. Not like crazy different, but it would be incredibly unlikely for a sample to have the exact same average as the population. Does that make sense to anybody? If you just go randomly select 20 people and then you compare their average age to the average age of everybody, you're like, well, that wasn't the same. Of course, it's not going to be the same. It's much more likely that you randomly select people of different ages, overall younger, overall older, something. Okay, maybe this is so weird, I know. Stay with me. Now, so since their ages are closer to their average age, the answer I get is going to be smaller than it's supposed to be.
And by supposed to be, you mean the
If
population?
I knew the real mean, I would get the right answer. But I only have their mean, and they will be closer to their own mean. I really want this to make sense. What's kind of funny
That
is
makes well, because you don't have the outliers that you could have gotten if you took the entire
it's
class.
much less likely that I would, yes. And
Okay.
whatever sample I take, the average for them comes from them. So of course they're going to be overall closer to the average than whatever the real average is. I really want that to make at least a little bit of sense. All right, so here's what we do. All right. So we do all the same stuff. We still do all the same stuff, right? Doesn't this look the same except there's an X bar instead of a mu? But when we go for the equation, I can't use this letter because that's for a population Greek population. I'm going to use the letter S. That should not be a surprise. Now here's the big difference, right? Letter S instead of letter sigma, our letter instead of Greek letter. Here's the big difference. You ready? I can't put an N there. And let me ask you this. I don't know if everybody's with me now. Or didn't we say that if I did the exact same thing, the answer would come out smaller than it's supposed to?
Yes.
If I want to make a division problem come out bigger, isn't that what I want to do here? If I just leave it like this, it's going to be too small. If I want to divide and make the answer come out bigger, do I divide by a bigger number or do I divide by a smaller number to make the answer come out
The
bigger?
percentage that the sample is of the population.
No.
Okay.
I appreciate that answer though, but that's sort of related to adjustments we make for other things. Let me just,
number.
you ready? I'm going to divide by less. If you divide by less, doesn't the answer come out bigger?
Mm-hmm.
If the
Yeah.
problem here is the answer is always going to be too small, what if I just do this? Is the answer going to be bigger now?
Yeah.
Yeah, and the funny thing is, this is exactly what we want to do. All right, so let's take a deep breath. So I want you to remember, there's an n-1 here because it's an adjustment for it being just a sample. So if I have just a sample, not the whole population, I should expect something to have to change, right? Does that make some kind of sense? If I just have a sample instead of the whole population, I don't know everything for sure. Something's going to have to kind of like adjust. And that is the adjustment we make for this. Now, let me say one more thing about n-1 because it's going to come up again later, believe it or not. All right, stay with me. This is weird. All right. I know. If I know, no, stay with me. If I know that three numbers average to be 10, that's all I tell you. Do you know any of the numbers?
No.
You don't have a freaking clue. But do you know what they all have to add up to be? What's the sorry? Say again.
30.
30, right? The only way three numbers can average to be 10 is if their sum is 30. Does that make sense?
Yes.
Because you sum divided by 3 is 10. Well, then the sum's got to be 30. So I can just make up. So I got three numbers. Somebody give me what the first one is. Just make it up. Give it to me. 7. Somebody else tell me the second number. Just make it up.
22.
Woo! 22. Now, can I just go free for all for the third one, or do I have to stop and go, wait a minute?
Stop and wait a minute.
Stop. Yeah. I'll let your math class figure it out. So what would the last one have to be in this case?
1.
1, exactly. So that it adds up to 30, correct? So how much freedom did we have? Would you say, let me just say this weird thing. Do we have 3 degrees of freedom? How much freedom did we have?
We had 2 degrees of freedom.
Yeah, I had 2 degrees of freedom. So if I have n things, n-1 is called the degrees of freedom. You can do my math, but you can't take away my freedom. No Braveheart people? Okay. So that's going to come up later. So that there is an actual mathematical basis for n-1. It didn't just come out of our ass, thank God. There's an actual thing it is. It's a thing that exists. And in this case, you can just think of it as an adjustment we have to make because this is just a poor little sample.
So the standard deviation for samples are annotated with the S.
Yes. Just
And-
like population mean is Greek letter, mu. Sample mean is our letter, X bar. Population standard deviation is sigma, Greek. Sample standard deviation is S, our letter. So no,
And could you say that the spread for a sample is smaller than the population spread?
not necessarily, no. The thing that this does is it makes, if I took all the samples I could and then averaged their standard deviations, this makes it come out to be the same as the population standard deviation. This is a little bit of an adjustment to make sure that altogether they make what the population really is. I don't know if that really answered your question well enough. Okay. Let's see. Go ahead. So I've got this. We're not gonna do today because I do want to keep my promise of letting us out of here a little early. Let me show you this. Jeff. Where is it, Jeff? Oh, I know where it is.
Quick question. What's X bar? Is it like the average mean or?
Well, if you say the mean, it doesn't make sense. There's a population mean, which is mu. So what's X bar? Mu is the population mean, so X bar must be the
sample?
Average of the sample.
sample mean. There you go. Kick
Okay.
ass. So if you go to Canvas now, let me publish this. There we go. Now you will see a standard deviation handout. All right. Do you guys notice how I used n-1 on this fully worked out example, right? And why
What's
did
the-
I do? Sorry.
What's the technical definition of n?
Number of things in your group.
Thank you.
Number of things in the group you're looking at. So you can call it sample size, but it actually also works for population if you're working with the entire population. So it's just the number of things you're working with. So in this case, there are 5 data points. So of course they're divided by 4 because it's a sample. So this is the first example of what I told you on the first day. What gets people down about statistics are not just the Greek letters, it's also the fact that the formulas change a little bit based on the situation. So this is a concept heavy class. I don't know if you've picked up on that yet or not, but so there's a concept that ties into the formula changing a little bit. All right. Now, I'm not going to make you memorize this formula. I'll actually give it to you, but I'm not going to give it a name. So I provide you a list of formulas and they are not identified. So you don't have to remember, you don't have to memorize the formulas, you have to recognize the formulas. Okay. So here's an entirely worked out problem all the way through. I've got some other freaky ass things I ask you here. And then there's another one on the back. And I think we'll do this first thing, what am I trying to say? Monday. Okay. All right. So you guys, I love it. You're not really sure how to react to that. Any questions? Otherwise, I'm going to let us go and you can start the quiz now if you want to, or it should open at 3:30. So you got a few more minutes. Okay. All right. So you guys are free to go. You're like, oh, that's a good note to end on, Jeff. Oh, well, have a good weekend. Good luck on the quiz and hang out with me if you have questions.
All right. It's your favorite annoying student. I'm gonna hang out for a minute while I figure out this homework thing just real quick.
Sure.
Because I just brought up the homework sheet and saw 1 and figured, okay, that's 1 day's homework. That was my logic.
I got
So
you.
flawed.
Yes.
Okay. I'm gonna dive into it while you're still on camera, and hopefully I have a question.
So what do you think was going to happen? Because I mean, this is a 6-week course, so I mean, once you got down to 11, you're like, I guess he's going to have a whole other sheet.
That's what I thought. You're just gonna add another sheet.
Damn.
Dude, I went to UCI before this. Like they would kick our asses like that.
All right. I don't kick the ass quite that hard. Anyway, so what's up?
I do have a question.
Yeah.
Just about percentiles. So like when you have your data values, do you have to put them in like numerical order first and then okay, I just wanted to make sure because I got a little bit confused earlier when we were going through it, and then I just wanted to confirm
Yeah.
that.
Yeah. Otherwise, you can make any percentile anything you want to, and then they
Yeah.
don't mean anything. Yeah. Yeah. Yeah.
Yeah, okay. I just want to make sure.
Sure.
All right, thank you.
Sure. You're welcome. Is everybody else okay? If you're
Professor, I have a question.
Yeah.
I don't think I'm scanning my work right, because I had issues with it in the past turning it in. So I know you said previously that there's a way when you scan, it could turn into like a PDF into one whole page versus like separate ones.
Yeah, depending on the app you're using,
Uh-huh.
you could actually scan several things into one file.
Right.
And it depends
So
on the app you're using, or you could do several scans and turn each one in, but all at once. So let me see if I can do this. So here, if I go to start assignment and I upload a file, do you see right here it says add another file?
yeah.
There you go. So before you hit submit assignment, you add all the files you need, and then you submit assignment.
I'm using the Canvas app on my phone, not the actual like scanning app. I don't know if they relate or something, but when
I
I turn
mean,
it in,
a scanning app is just an app that's able to scan work on a piece of paper. So if Canvas has an app that does that, great. I don't, that's news to me.
Adobe's really easy to use.
okay, because I'm like, I don't want, because I know my
And-
work,
and-
on my
Look-
work, it says incomplete. So does that mean like you didn't get it?
Okay, and so, all right, there's a whole thing here about how to view the feedback that I've given right here. How to
Yeah.
view the notes. Okay, so you can view the notes and see exactly what went wrong.
Yeah. But what
Okay.
does it mean by saying incomplete? Does that mean like I just need to make corrections and then turn it in possibly?
Normally, it
Okay.
could also mean you need to finish it. It could also mean you need to both. It could also mean you need to redo it.
Okay.
So that's why you look at the feedback, so you can tell
Right.
exactly what went wrong. Yeah,
Right. Okay. Just wanted to make sure.
sure. Okay. How's everybody else? You guys, are these all the people that aren't really there? Is that what it is?
I have a question for, I'm on the homework 1.3, the first 139. Question B, baking temperatures for various main dishes, 350, 400, 325, 250, 300.
Yeah. Mhm.
I mean, if you're cooking, that's basically nominal.
Those are numbers, aren't they? Couldn't I tell you to decrease the temperature by 20 degrees? Would you subtract 20 degrees from something? If you had it
Okay.
at 400 and I said decrease it by 20, wouldn't you do 400 minus 20 to get to 380?
So it's interval.
Yes.
Thank you.
You're welcome.
I really appreciate your time, man. You make this palatable.
Sure. But in general, on these kind of problems, you first say to yourself, are these like really numerical or are they not? And temperature is a measurement. So it's pretty much always going to be like a really numerical thing, right? Because when I'm measuring something, it kind of goes up by increments. That's going to be a real number. And then it's just a question about, is it interval or is it ratio?
So social security numbers would be ordinal because they're given out to babies
Yeah,
as
we
they're
talked
born.
about that in class a little bit. I said I could accept ordinal, but it really is nominal. Yeah. It really is just another name for you. They're given out based on state, and they're probably given out in some kind of order within that. But the real intent of it is another name for you.
Okay.
Yeah.
incomes measured in dollars would be a interval because it's based on subtraction, correct?
Is that all you can do with the numbers? If you made
Oh,
20,000.
they have an order, so it's ordinal.
No. Listen. Interval, it definitely is at least interval, so it's not going to just be ordinal. Your answer is always the highest level.
And that would be ratio.
Yes, why?
Because you can find averages and division. Well, I have the written down from notes. Division makes sense. Blank.
Division makes sense. So give me an example. Like if I made 20,000 and you made 40,000, 40,000 divided by 20,000 is 2. Does that mean something?
That means I made twice as much money as you.
Done. Ratios mean something. Therefore, it is ratio. Right. Also, 0 means what it's supposed to. 0 is supposed to mean absence of thing. So if somebody had 0 income, that's absence of income. But if it was 0 degrees outside, that's not absence of heat. Can it get colder? Yes. Does that make sense?
Got you.
Yeah. Somebody came back. Neat. Is anybody else out there? You guys have questions? I mean, if you don't have questions, you can head out. I don't understand. Okay. I'm going to stop.